Here we go, you guys, with inequalities, example number 3. Let's get after it. You have the notes and everything. And again, example 3, and I will put the notes up. You have these in front of you. Keep them with you. So once again, no matter what, the way I prefer you learn this, and I've tried many ways, let's always do the equation. And that should be, again, once again, a flashback. So I'm going to solve these equations fairly rapidly. This one is a quadratic equation, so you'll notice that since there are multiple terms that contain x, I'm getting it in standard form, making it equal 0. This is assignment 11. And then let's hope that that will indeed factor. These need to be opposite signs, don't they, to get a negative third term. This is assignment 5, factoring. I believe that if we do x plus 4 and x minus 12, wouldn't that give us everything, you know, if you FOIL that out? So then we set each of those expressions individually equal to 0. Sure hope I've done everything right so far. Of course, if you make a mistake here, you're in trouble. I'm pretty sure everything's good. So this equation leads to x equals negative 4, and this one would lead to x equals positive 12. Okay, so we have two numbers that will make these two expressions equal. And then, of course, we always check for division by 0, question mark, all right? And since there's no fractions here, that's not a concern. So you're only going to have that issue of division by 0 if there's fractions involved in the question. And example 1 had fraction in it, but this one does not. So we have negative 4 over here. We have 12 over here. These are values of x. This is a number line representing the variable x. All right, let's talk about whether to include or exclude these numbers in the final answer. It all depends on this. Equal is in the question, isn't it? So if you're a number that makes those two expressions equal, then you're good, you work, right? So in this case, equal to, and so I would remind you that visually what I like to do is I put a solid dot there to indicate that yes, you're a solid answer to the question. And I'll say it one more time. It's not memorization, anything. Let's look at the problem. Equal, it's in there, yay. So that is a relationship that satisfies the question. All right, every question I'm doing is identical. Equation, number line. Okay, two things to think about, two things to remember to do. The number line part of it depends on your arithmetic skills. To be a total snob about it, you're going to pick a number below negative 4. I like negative 10. All right, and so this would be negative 10 in parentheses squared minus 8 times negative 10 over here. And then we've got 48 on the other side, and it's really arithmetic. You crunch the numbers. So negative 10 squared is positive 100. Parentheses are important. Negative times negative, that becomes plus 80. 48. What's the relationship? Well, this side's 180. You know, do all the math, right? Crunch this side, crunch that side. Get two numbers, see how they're related. All right? At the end of this, you look at this and go, yeah, 180's greater than 48, and you look up here and go, yay, greater than. Yes, that's a relationship that we want. That's awesome. So greater than, yeah, look what you got, look what's in the problem. If they match, you go, it worked. And that region, therefore, that interval, I'm shading it in. I'm going, yeah, when I write my answer up, I'm going to include that interval in my answer. That's the whole point of this. What numbers work in the question? Okay, then we pick a number between negative 4 and 12. I would pick 0. 0 makes the easiest math possible. So when you, when you put 0 in for x, 0 squared is 0, and 8 times 0 is also 0. And this side's just 48 every time, isn't it? No math going on over there. And so then we end up with 0, 48, and you ask yourself, well, how does 0 compare to 48? And you say it's less than, and you look up here and you go, no, the question wanted numbers that make it greater than. That middle interval, that neighborhood between here and here is going to give you less than. And that, oh, no, that's no good. We don't want that. Okay? I have sound effects for these things. I got to keep things going here. All right, then we'll test a number out here bigger than 12. You can do 100, you can do 20. I'm doing 20. I picked numbers that end in 0. So anyway, I'll write this out. 20 squared, which by the way is 400, and then 8 times 20, and then 48. I always put a question mark here because we're not done doing the math. Just like at the beginning stages of a date, you got to spend time together. You got to evaluate, you crunch numbers. 20 squared is 400. 8 times 20 is 160. 48 sitting over here. The date's not quite over. We pause at the door. We subtract. We end up with 240 over here, and that's 48. And 248 is greater than 48. Greater, right? You look up here and go, yay, greater! So I'm picking that good old green, good, yes, matches it. Yeah? And so that interval works as well. So there you go. This time we ended up with these two intervals on the outside. As I'm erasing to make room for other things, I'll just give you a quick, my old man rant. There are some books and some people that would have you memorize patterns for all these different kinds of inequalities. I used to do that. I once taught it that way. It was disastrous. Okay? So instead of trying to learn like 4 different approaches, and each one of these types of equations has a different technique that we could talk about, and then every one of those has exceptions, by the way. So in my experience, keeping them separate from each other and remembering the exceptions on each one, it was disastrous. That was years ago. And finally, looking around, looking for different ways to do things. Other people, other books do this. This works on all of them. I like that. It's one approach that's unified. Ever since I started teaching this way, things have gone way better. So, there you go, old man rant. Okay, so from left to right, here we go. Go forever in the negative direction. I hope you all realize that that's written as negative infinity. Right, so if you go forever, that's infinity, that's a sideways 8. And by the way, infinity would always have a parenthesis next to it. The idea being, it's a theoretical discussion, but basically it's impossible to equal infinity, and equal is a bracket, so if you can't equal infinity, by default, you're going to have the exclude on it. So parenthesis negative, and this is always written left to right, read it like a book. Let's see, negative infinity to -4, and then that's included because equal was in the question, so we'll put a bracket there. All right, that looks good. We got that piece. And then this one from left to right, always left to right, that's just the standard way of doing it. So let's start here at 12, and we'll put a bracket next to it. That's the include symbol, and that would go to positive infinity, and that always has a parenthesis. All right, now, Mr. Septic Tank would accept this. And I know a lot of people in the world who would count the whole question wrong for a little thing. It's probably important, but look, whatever, life's too short. This is the interval, this is the interval. Any x that lives in either one is going to work. Now, that's a good enough answer for me. But at other places, they might insist that you would say, if you live here, or you live there, and so to make it a better answer, you could put the word or in between there. And that makes it just a little bit better. Any value of x that lives here, or here. So if you have multiple intervals, okay, the word or. Okay, that's cool. That makes it a little bit better. All right, now, let's make it purely the best mathematical answer. There is a mathematical symbol for the word or. And to make this even better, to make the total math nerds really happy, the word or is symbolized with what's called a union symbol. It's just a big old U there. That's a U, not a V. And there you go. So that would be preferred. And so please try to remember to put that in there. To be honest with you, if you don't put it there, I can't find it in my heart to count the whole question wrong just because of that. So maybe I'm supposed to. I don't know. So when I do something nice, I got to make a big deal out of it. So speaking of the infinity symbol, the sideways 8s, if you will, I just wanted to share with you as we sign off here on this one that when my daughter's now 21 years old, all right, and but when she was 10, we went out to a restaurant and ordered some sandwiches. And you know how when you order your sandwich or your food, they'll give you a number to put at your table so that they'll bring it out to you. Well, and this is a live video link to my daughter there at the restaurant. So hi Andy. So the number they gave us was infinity. So there she is still waiting for that sandwich at the age of 10. I guess she still looks like she's 10. She's now 21. But it looks like we're going to be waiting forever for that sandwich, don't you think? Love you, sweetie. Let me know when that sandwich arrives, if ever.